Good morning everyone. I hope you are all doing well. My name is Dr. Amar Kumar De and I am excited to welcome you to today's lecture titled Analog Communication System Advantages and Limitations Applications for the course Fundamental of Communication System and its Application. It's exciting to see so many of you joining us from different corners of the world. First and foremost, I want to extend a warm thanks for taking the time to be a part of this session. So, without further delay, let's move on to the topic titled Analog Communication Systems Advantages, Limitations and Applications. Before moving ahead, here's a quick overview of today's lecture. First of all, we start with the basics of analog communication system. In this, we are going to cover definition and principles. Next, components of analog communication system, then types of analog modulations. Then we will discuss the advantages of analog communication system. In this, we are going to cover simplicity of design and implementation, cost effectiveness, real-time processing, high quality audio transmission, analog signal representation. Then we move on to the limitations of analog communication system. In this, we are going to cover susceptibility to noise and interferences, limited signal processing capabilities, bandwidth requirements, power consumptions, limited security. Then we are going to take the applications of analog communication system. In this, we are going to cover first the broadcasting, then telephony, then two-way radios, and then audio and video transmissions. Finally, we will have the conclusion, and in this we are going to cover first the summary of key points and then the future of analog communication in this digital scenario. To start our discussion today, let's dive into the fundamental concepts of analog communication system. First and foremost, we need to grasp what this analog communication system is. Analog communication is the process of transmitting information through continuous signal that varies in amplitude, frequency or phase. Unlike digital communication, which encodes data into discrete binary numbers, analog communication relies on waveform that smoothly changes over time to convey information. This waveform can represent various forms of signals such as sound wave, radio waves or other types of electromagnetic waves. Let's explore the core principle of analog communication that underpin its operation. First is continuous signal. In the realm of analog communication, information is depicted by continuous waveform. This signal exhibits smooth and uninterrupted variations in amplitude, frequency or phase over time. This continuously allows for a rich representation of values, making the analog signal well suited for transmitting complex informations like audio and videos. Then waveform properties includes first the amplitude. The amplitude of the signal indicates the strength or intensity of the wave. For instance, in an audio signal, the amplitude corresponds to the loudness of the sound. Next characteristic is the frequency. It measures the number of cycle or oscillations a wave completes per second expressed in hertz. In audio signal, frequency determines the pitch of the sound. Next is the phase. It represents the wave position relative to the reference point in time. Phase modulation, for example, involves altering the phase of the waves to encode the information. With this principle in mind, let's break down the key component of analog communication system. The first important component is the transmitter. It is used to convert the information into an analog signal ready for transmission. It's typically comprising a source of the original information such as a microphone for audio signal, a modulator to encode the information onto a carrier wave, and an amplifier to strengthen the signal for transmission. The next component is the channel. It is the medium through which the analog signal travels from transmitter to receiver. The medium can be physical like copper wire or fiber cable, or a wireless medium such as air or space. The channel characterizes can introduce noise and distortions, imparting the signal quality. The last component is the receiver. The receiver job is to capture the transmitted signal, demodulate it to retrieve the original information and convert it back into a usable form. It typically include an antenna or other receiving device, a demodulator to recover the signal, and an amplifier to enhance the strength of the received signal. As we navigate through this concept, we will gain a deeper appreciations of how analog communication systems operate and their role in transmitting information seamlessly. Before moving ahead, let's have a quick overview on the types of analog modulations. The first one is amplitude modulation. Amplitude modulation involves varying the amplitude of the carrier wave in proportional to the information signal. The frequency and phase of the carrier waves remains constant. Next is frequency modulation. Frequency modulation involves varying the frequency of the carrier in proportional to the information signal. The amplitude and the phase of the carrier waves remain constant. And the last one is the phase modulation. Phase modulation involves varying the phase of the carrier wave in proportional to the information signal. The amplitude and frequency of the carrier wave remains constant. With these key concepts of analog communication system covered, we can appreciate how they influence the design and functionality of our analog communication system. Now, we will explore how these principles are applied in real world scenario. Now that we have a solid grasp of the basic, let's explore the advantages of analog communication system. This benefits underscore why analog communication remains vital in various applications despite the rise of digital system. First one is simplicity of design and implementation. To begin, one of the standout features of analog communication system is their simplicity in design and implementation. Simple hardware requirement, analog communication system offers a straightforward and well understood hardware component. Devices like amplifier, oscillators and filters are fundamental and relatively simple to design and build. For example, constructing an AM radio transmitter involves basic components such as microphone, modulator, amplifier and antenna. Similarly, the receiver used simple circuits to demodulate and reproduce the original audio signal, making the system both accessible and efficient. Easy to design and implement. Compared to digital system, analog communication systems are generally more straightforward to design and implement. This simplicity arises from the lack of complex encoding and decoding processes. Another key advantage is the cost effectiveness of analog communication system. Lower initial cost compared to digital system. Analog communication system typically have lower initial setup cost. The components and equipment need for analog communication systems are often less expensive than those required for digital system. For example, setting up an AM or FM radio stations include lower cost than a digital radio stations, which demands for more advanced technologies and infrastructures for digital signal processing, compressions and transmission. Less complex equipment. The equipment used in analog communication system is usually less complex and more readily available. The simplicity translates to reduced cost of maintenance and repair. An analog audio recorder, for instance, use straightforward magnetic tape mechanism which are less expensive to manufacture and maintain compared to the digital record device that required digital to analog conversion and storage system. Let's now consider the real-time processing capabilities of analog communications. Immediate signal transmissions and reception. analog communication allows for immediate transmission and reception of signal. The real-time processing capabilities is particularly beneficial in applications where instant communication is crucial. In live radio broadcast, for example, the audio signal is transmitted and received in real time, allowing listener to hear the broadcast with minimum delay. This immediacy is vital for live sports commentary, emergency broadcast and live music performances. No need for signal conversion. Analog systems transmit signal in their natural form without needing to conversion to and from digital formats. This absence of conversion reduces latency and simplifies the communication process. For example, in an analog telephone system, the human voice is transmitted as a continuous electrical signal directly through the network, avoiding the delay associated with analog to digital and digital to analog conversions required in digital telephone system. The next advantage is the high quality audio transmission. Analog communication also excels in certain aspects of audio quality, that is the superior audio quality for certain applications, example FM radio. Analog communication, especially the frequency modulation, is known for its superior audio quality in specific applications. FM radio, for instance, offer high fidelity sound with a wide dynamic range, making it ideal for music broadcast. The continuous nature of analog signal allows for richer and more natural sound reproduction compared to the compressed digital audio format, which can sometimes lose nuances during the compression process. Analog signal representation. Lastly, the accurate representations of original signal is another significant advantage. Analog representations of original signal in some context, example sound. Analog signals provide an accurate and direct receptions of original signal, which can particularly be advantageous in applications involving sound. For example, vinyl records capture and reproduce sound in its natural analog form, preserving the depth of the original recording. Audiophiles often refers analog recording because they believe that the analog sound reproduced retains more of the original audio characteristic and detail compared to that of the digital format. In conclusion, the advantages of analog communication system highlights their continuous relevance and importance in various applications. This simplicity, cost effectiveness, real-time processing capabilities, high quality audio transmissions and accurate signal representations makes them valuable in numerous contexts. While digital communication has become predominant in many areas, the unique benefits of analog systems ensure they remain integral to specific applications and industry. Understanding these advantages provides a comprehensive view of why analog communication system has been and continue to be an essential part of the communication technology. Having explored the advantages of analog communication system, it's equally important to understand their limitations. This will give a balanced perspective of their practical applications and why digital communication has become more prevalent. So, let us begin with one of the most crucial drawback of analog communication system, their susceptibility to noise and interferences. Analog systems are easily affected by noise. One of the most significant limitation of analog communication system is their susceptibility to noise. Noise which can be electrical interferences from various sources such as electronic device, power line or environmental factors like lightning can easily contaminate analog signal. This contamination is due to the continuous nature of the analog signal, where any signal variation caused by noise can distort the signal. For instance, in an analog television broadcast, electrical noise caused by static and variable interferences in the picture quality, degrading the viewing experience. degradation of sound quality over distance. As analog signal travels over long distances, they tends to weaken and degrade, a phenomena known as attenuation. The further the signal travels, the more it affected by loss of amplitude and introduce of noise, resulting in a poor quality signal at the receiver end. This degradation is particularly evident in long distance telephone calls using analog line, where the voice quality diminish and may become distorted or lossy. Next, let us consider the limited signal processing capabilities of analog communication system. Less flexibility in signal processing compared to digital systems. Analog communication system lack the advanced signal processing capabilities that digital signal processing has. In digital system, signal can be easily manipulated, compressed and error corrections using sophisticated algorithm, which is not possible in case of the analog scenario. Analog system, on the other hand, are limited to basic processing techniques such as amplification and filtering. These limitations restrict the ability to perform complex operation like noise reduction, signal enhancement and secure encoding, which are essential in modern communication applications. Bandwidth is another area where analog communication systems face significant limitation. Analog communication systems often require larger bandwidth. Analog signals typically require more bandwidth than digital signals to transmit the same amount of information. For example, an analog television signal required a broad frequency spectrum to transmit both the audio and the video component without losing the quality. The larger bandwidth requirement can lead to some frequency constraint in the spectrum, making it difficult to allocate sufficient bandwidth for other communication services. Bandwidth constraint in certain applications. In many applications, available bandwidth is limited and must be shared among multiple users and services. Analog communication system with their larger bandwidth requirement can struggle in environment with tight bandwidth constraint. For example, in crowded urban area where many radio stations operate, the limited availability of frequency can lead to interferences and reduce signal quality for analog broadcast. Let's now address the issues of power consumptions, a critical consideration in communication system. Higher power consumptions to digital system. Analog communication system generally consumes more power than the digital system. This higher power consumption is due to the continuous nature of analog signal, which required constant transmission and amplification to maintain signal integrity. For instance, analog radio transmitter must continuously broadcast signal consuming significant amount of power. In contrast, digital system can use power saving techniques such as packet transmissions and signal compressions to reduce overall energy uses. Inefficiency in signal transmissions and receptions. The inefficiency in analog signal transmission and receptions contribute to higher power consumptions. Analog systems often require stronger signal to overcome noise and interferences, leading to increased power output from the transmitter. Additionally, receiver in analog system must operate continuously to produce the incoming signal, further adding to the power consumption. This inefficiency is particularly problematic in battery powered devices like portable radio and analog mobile phone, where prolonged use can quickly drain the battery. Security is another area where analog communication system lags behind their digital counterpart. Easy for analog signal to be interpreted and manipulated. Analog communication signals are relatively easy to interpret and manipulate, since the signals are transmitted openly over the airways or through unencrypted cables. Anyone with the appropriate equipment can receive and decode them. For example, analog cordless phone conversations can be intercepted by nearby scanner, allowing the eardroppers to listen in on private conversation. Similarly, analog radio broadcast can be easily jammed or interfered by the malicious entries. Lesser secure compared to digital signal. The security of analog communication system is inherently low than that of the digital system. Digital system can employ advanced encryption technique to protect the data being transmitted, making it difficult for unauthorized parties to access or alter the information. Analog system, however, lacks some robust security measure. For example, digital mobile phone uses encryptions to secure voice and data transmission, while analog mobile phone do not, make them more vulnerable to interpretations and misuse. Understanding the limitations of analog communication system provide a comprehensive view of why the digital communication has become more prevalent in recent years. Despite their simplicity and cost effectiveness, analog systems face significant challenges in terms of noise susceptibility, limited signal processing capabilities, bandwidth requirement, power consumptions and security. These limitations highlights the needs for ongoing advancements and the shift toward digital communication technologies, which offer most robust, efficient and secure solution for modern communication needs. Now, let us discuss the applications of analog communication system. We started with one of the most familiar use of analog communication, that is the broadcasting. AM, FM radio broadcast. Amplitude modulation AM radio is one of the earliest applications of analog communication. In AM radio broadcast, the amplitude of the carrier wave is varied in accordance with the amplitude of the audio signal. AM radio can cover large geographical area, making it suitable for rural and long distance communication. Despite its susceptibility to noise and interferences, AM radio remained popular for talk show and news due to its extensive reach. Frequency modulation. FM radio broadcasting involves varying the frequency of the carrier wave in line with the audio signal. FM radio provides superior audio quality compared to AM, particularly in music broadcast, due to its higher resistance to noise and interferences. The use of frequency modulation allows for better sound quality fidelity and less statics, making FM the preferred choice for music stations. In television broadcast, TV broadcast transmission, video and audio signals use amplitude modulation for video and frequency modulation for audio. Before the advent of digital TV, analog televisions was the primary means of delivering the visual content to household. Although the analog TV has largely been replaced by digital system, it plays a crucial role in the dissemination of information and entertainment for decades. Moving on, let's explore the role of analog communication in telephony. Telephony. Traditional landline telephone relies on analog communication to transmit voice signal. In this system, the human voice is converted into electrical signal by the microphone in the handset, transmitting through the telephone network and then covering back to sound by the speaker at the receiver. Analog telephony is known for its simplicity and reliability, though it is increasingly being supplanted by digital and voice over internet protocol system. Early mobile phone communication system. The first generation 1G of the mobile communication system was based on analog technologies. This early mobile phone used frequency modulation to transmit voice signal over cellular network. While they provided the foundation for the mobile communication, these analog systems were limited by poor signal quality, high susceptibility to endeavor droppings and lower data transmissions capabilities compared to modern digital system. Now, let us discuss the crucial applications of analog communication in the two-way radio. Walkie-talkies. Walkie-talkies are portable two-way radio transceiver that used analog modulation techniques, typically frequency modulation, to enable short-range voice communication. They are widely used in various settings such as outdoor activities, construction sites and event management due to their simplicity, reliability and the ability to function without a centralized network. Emergency communication system. Analog two-way radio are crucial in emergency communication system, including those used by police, fire department and emergency medical services. This system provide reliable intermediate communication which is essential during emergencies and disasters. The robustness of analog signal ensure that communication remain possible even in area with poor network coverage or unsuitable where digital systems may fail. Now, let's turn on our attentions to how analog communication system is used in audio and video transmission. Analog audio recording and playback. Analog audio recording involves capturing sound waves as continuous electrical signals which are then stored on medium such as magnetic tape or vinyl recording. Analog playback devices such as cassette players and recorders player read this signal and convert them back into sound. Analog audio is prized for its warmth and fidelity, especially in high fidelity music system. In summary, analog communication system, despite the rise of digital technologies, continues to play a significant role in various applications. Their simplicity, reliability and ability to produce real-time communication make them indispensable in specific contexts such as broadcast, telephony, two-way radio, audio and video transmissions. Understanding these applications highlight the enduring relevance of analog system and their contribution to modern communication system technologies. Let's wrap up our discussion on analog communication system by summarizing the key points and exploring the future in digital age. But first, let's quickly recap the essential aspects we have covered. Recap of the key points. To begin, let's revisit the foundation aspects of communication system, analog communication system. This system has played a crucial role in historical communication technologies, relying on continuous signal to transmit information. Various modulation techniques such as amplitude modulation, frequency modulation, phase modulations are used. Key components include transmitter, channel and receiver, with analog signals characterized by their amplitude, frequency and phase. Effective transmissions hinges on meeting bandwidth requirement. Transmission to benefit analog communication system offers significant advantages. They are noted for their simplicity in design and implementation, making them accessible and cost effective with less complex hardware. Their ability to process signal in real time without conversion ensures immediate transmission and reception. Certain applications like FM radio benefits from superior audio quality and accurate signal representation. Despite this advantage, analog systems face noticeable limitations. They are highly susceptible to noise and interferences which degrade the signal quality over distances. Compared to digital system, analog systems has limited signal processing capabilities and offer required larger bandwidth which are constrained. Additionally, they consume more power and less secure, as analog signal can easily be interpreted and manipulated. Analog communication systems remain relevant over various applications. They are crucial in broadcasting AM, FM, radio and television, telephony, landline and early mobile communication systems, two-way radio, walkie-talkies and emergency systems, and audio-video transmissions, analog recording and playbacks. Having reviewed this point, let's consider the future outlook of analog communication in our increasingly digital world. Future outlook of analog communication in a digital age. As we delve into the future, it is evident that the role of analog communication system is evolving. Digital technologies may dominate many areas due to their robustness, effectiveness and versatility. Yet, analog communication system still holds significant values in certain contexts. Analog communication systems thrives in niche applications where their unique advantages are crucial. For instance, FM radio remain popular for superior audio quality and widespread accessibility. In professional audio recording and broadcasting, analog equipment is often favored for its warmth and fidelity. Additionally, certain scientific and industrial measurement depends on the precise representation of analog signal. Next, the future will likely see more integration of analog and digital technologies, leading to hybrid systems that leverage the strength of both. For example, analog signal might be digitalized for processing and then converted back for transmission or vice versa. This approaches enhance the performance and capabilities of communication system, combining the real-time processing of analog with the precision and flexibility of digital. Furthermore, understanding analog communications remain essential for education and training in communication engineering. Analog principles form the foundations of learning about modulation, signal processing and system design, providing a comprehensive background invaluable for mastering the digital communication technologies. Additional technological advancement could breathe new life into analog system. Innovations in material, circuit design and signal processing might migrate some traditional limitations of analog communication, such as noise susceptibility and power consumption. For instance, new filtering technique and lower noise amplifier could improve the analog system performances. Moreover, analog system can offer redundancies in communication network in situations where digital systems may fail to compromise. Analog systems can serve as a reliable backup. This is particularly relevant in emergency communications and remote areas where digital infrastructure might be lacking. So, with this, we have come to an end of today's lecture. Thank you for your attention. Before we conclude, I want to take a moment to thank all of you for your participation and attention throughout this lecture. Your engagement make this session truly rewarding. I appreciate your decision to learn and hope that today's lecture has provided you with valuable insights to analog communication system, advantages and limitations, applications. Once again, thank you for joining today's lecture. I am looking forward to see you in my next classes. Take care. Have a great day.